Alrighty guys, we're going to go ahead and get started with our electrostatic force notes. So the first thing I want to talk about is the fact that electrostatics is everywhere in our lives, and we see it every single day, especially now during the winter. Static electricity is a part of the everyday world that we experience in which electrostatics is involved. You guys will notice now that maybe when you come home, you take off your coat, and then you touch like a doorknob or something and you get a little shock. That static electricity is a result of electrostatics. Clothes in the dryer that cling together, another example of electrostatics. They're clinging together because of their charges. You walk around the carpet and you get shocked by the doorknob, right? If you've ever dragged your feet across the carpet, maybe you did it really quickly and then you went and touched like one of your friends or something, that it shocked them. Same thing, you're grabbing charges from that carpet, putting it on yourself, giving yourself an uneven amount of charges, and then when you touch the doorknob, it's going to neutralize you, meaning that the charges from you are going to transfer to the doorknob, so that instead of you having a bunch of extra charges, you now have the perfect amount of positive and negative charges. If you have a pet, like a cat, you'll notice that the cat's fur might stand up sometimes. Same thing, the reason the fur is standing up is because we have all these charges repelling each other, which is making the fur stand. Bolts of lightning dashing across the sky during a storm are just a bunch of charges up there in the air. Let's talk specifically what is static electricity. And we're going to say that static electricity is a stationary electric charge that is built up on the surface of a material. Over here in my picture, we can see this little girl touching this metal sphere, and the metal sphere is putting these charges onto her. So it's building up these electric charges, and that's what's happening to her hair. Her hair has a bunch of these charges, a lot of electrons, and we remember that electrons have negative charge, so all these negatives are repelling each other, making her hair stand up. Electrostatic forces can be both positive and negative, and we'll talk about which ones are positive and negative in a sec, and they hold the world of atoms and molecules in perfect balance. Without this force, materials, objects, and life as we know it would not exist. So we are very grateful to electrostatics because we need it in order for life to function. Let's talk about the structure of an atom. And you guys have heard about atoms before. But basically, all we want to know for this class is that atoms depend on electrostatic forces. A proton and an electron have an equal amount of charge, but opposite types of charge. A proton, the little plus one over there, is going to be positively charged. This yellowish one that I'm showing you, and again, these aren't the actual colors, it's just the colors I'm using in the demonstration, is called a neutron. And a neutron has neutral or no charge. And then lastly, we have an electron, and an electron has a negative charge. So notice in this atom, we have 3 electrons and 3 protons, which means that it is neutrally charged. It does not have a positive or negative charge because it has the same of both. Let's dig deeper into these charges, and let's note that protons and neutrons are a part of the nucleus. We saw that on our last slide. Electrons are going to surround the nucleus and can be transferred between materials. The number of electrons will determine whether or not an atom is electrically charged or electrically neutral. So let's take a look at charged versus uncharged particles. Positively charged means that we possess more protons than electrons. Negatively charged means that we have more electrons than protons. And neutral means that we have an equal number of protons and electrons. This makes sense because positively charged is going to result from those protons, right? Protons are positive, so the more positives we have, the more positively charged we are. Negatively charged is going to be a result of having a lot of electrons, so the more negative charges we have results in a overall negative charge. And neutral means that we have to have the same number of both, same positive and same negative. I want to quickly talk about the fact that we said electrons can transfer between atoms. And one of the main reasons is because if we look at our diagram over here, we're going to note that electrons are on the outside of this diagram. It means that it's easier for these electrons to escape this atom. If we wanted to pull a proton off of this atom, it would be very difficult because we'd have to pull this proton past all these other electrons and it's already scrunched up in the middle next to those neutrons. The only charges that are going to be moving between atoms are going to be those electrons, because like I said, they're on the outside, they're easy to lose, so they're easy to just jump from one atom to another. Let's talk about charge interactions. And over here, we're going to say that two types of electrical charges, right, those positive and negative charges, can interact with each other. And we want to see what happens in these scenarios. Well, there's really only two scenarios involving positive and negative charges. And one of the scenarios is when one charge is positive and one is negative, as we can see in the bottom left. And that just means that for oppositely charged objects, they will attract one another. The opposite is going to be like charges. And we see that in the bottom right, how we have two negatives and two positives, and how they're pushed apart and they're spread out, meaning that like charges will repel each other. So just to summarize it, opposites attract and likes repel. Where do charges come from? That's a great question. So when a balloon rubs a piece of wool, electrons are going to be pulled from the wool to the balloon. And we can see in our diagram over on the left that these electrons are being transferred from the wool to the balloon. The balloon now is going to be negatively charged because it's acquiring all of these electrons. So the more electrons it has, the more negative it becomes. But the wool is losing these electrons. So because it's losing electrons, that means that it's going to have less of them. The less negative charges it has is going to result in the wool becoming positively charged. Rubbing materials does not create electric charges. It's only going to transfer electrons from one material to the other. You can't create charges because charges are energy, and we talked about that before. What you can do is transfer energy, and in this case, transfer charges. So let's talk about charged and neutral objects now. And we're going to say that any charged object, whether it's positively charged or negatively charged, will have an attractive interaction with a neutral object. Positively charged objects and neutral objects attract each other. Negatively charged objects and neutral objects attract each other. So neutral objects are attracted to any charged object. Neutral objects are not attracted to other neutral objects, but they are attracted to positive or negative charges. So we're going to say that the charge possessed by an object is often expressed using the scientific unit known as coulomb. We abbreviate with a capital letter C. And the charge on a single electron is negative. Notice how it's negative because electrons have a negative charge. Negative 1.6 times 10 to the negative 19th coulombs. This is a very, 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 very small number, which makes sense because electrons are very, 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 very small. The charge on a single proton is going to be the same number, except this time it's positive. So a proton is positive 1.6 times 10 to the negative 19th coulombs. I will give you these numbers. I don't expect you to memorize them. You can easily just Google these numbers too, but it's good to see them right now. Let's talk about electric fields real quick. And we're going to say that field lines for charged particles are drawn as arrows. And we can see below how they look. So here's two negatively charged objects on the left side. And if we notice, we can see that these field lines for negatively charged particles are drawn inward towards the particle. So negatively charged particles have field lines that point in. If we have two of the same type of particle, we're going to notice that these field lines don't flow into each other because they're both pointed towards the center of their objects. But if we look on the right side where we have a positive and negatively charged object, we see that the positive field lines point outward and the negative points in. So the positive charged field lines point into the negative charged field lines. And that is why these two objects attract each other. The key takeaway here, like I said, is that the negative field lines point in and the positive field lines point out.